Now, this is a final lesson on geometric reasoning. We are actually going to look at similar triangles. First, let's look at similarity, the famous Mona Lisa. Let's look at 1, 2, 3, 4, 5. 5 versions of the Mona Lisa. Do you think these two actually look similar to that one? Not really. Both of them don't. What about these two? Yes, they are more or less similar to that, except this is a reduction of that one, same as this. Or you can say that one of these is probably an enlargement of that, or this is an enlargement of that. So it actually doesn't really matter as long as they are similar. Whereas, look at these two. It's sort of elongated, and this is lengthened. Therefore, you can see that they are not similar to that. What are the similarity tests? In similar figures, all pairs of matching sides are in the same ratio, and all pairs of matching angles are equal. These are the two conditions to have similarity. Now, let's start by looking at this. We've got the picture of Mona Lisa 1 and picture of Mona Lisa 2. Corresponding sides AB, PQ. Corresponding sides BC and QR, CD and SR, and AD and PS. So, the condition states that all pairs of matching sides are in the same ratio. Therefore, ratio of AB over PQ should be the same as BC over QR, should be the same as CD over SR, should be the same as DA over SP. So, the corresponding side, they have the same ratio. Now, the matching angles are equal. So you can see the angle A is the same as angle P, B is the same as Q, C is the same as R, and D is the same as S. They are all 90 degrees. For a similar triangle, in this case, the matching pair of the sides, look at that. The angles are the same, that's the same, and that's the same. For the smaller one, this is similar to this because this angle is the same as that one, that is the same as this, and this is the same as that, and so on and so forth. Now, this is actually similarity. The two conditions, all pairs of matching sides are in the same ratio and all pairs of matching angles are equal. Let's have a look at similar triangle. How do we prove that the two triangles are similar? Right, before I go into details of similar triangles, this is actually a summary. There are 4 tests that you can do to prove that two triangles are similar. One is AAA, or known as angle, angle, angle. 2 is SSS, side, side, side. 3 is SAS, side, angle, side. And 4 is RHS, right angle triangle, right angle actually, hypotenuse and side. I will go through individual one very carefully, but this is the summary, the notation that you require. If triangle ABC is similar to triangle DEF, we can write that ABC is similar to DEF, or ABC is similar to DEF, either the squiggly line or the 3 parallel vertical line. That means similar. Let's have a look at the first proof, AAA or AA. Now, we are given 2 triangles ABC and DEF, and we need to prove that both triangles are similar. We know that triangle ABC, the angle A is the same as angle D of triangle DEF because they are both 72 degrees. Angle C in ABC is the same as angle F in DEF because they are both 35. We don't actually need to work out angle B or angle E because you know that the 3 angles add up to 180 degrees. Once we know these two, by power of deduction, we know that. So we can write in triangle ABC and triangle DEF. Angle BAC is the same as angle EDF and is 72 degrees. And angle BCA is the same as angle EFD, which is 35 degrees. Therefore, we can say that they are similar triangles. The reason is AAA or AA. Angle, 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 or angle, angle. It is fine if you use angle, angle only, because once you know these two angles, you can find the third angle. Now, let's do an example. We need to prove that the two triangles in the diagram to the right are similar. So basically, what we are required to do is to prove that ABC and PQC, they're similar. So we know that in this triangle, ABC and PQC, this angle is actually common. The way we write it is in triangle ABC and triangle PQC. Angle C is the common angle. Right? So now we need to prove that angle B is the same as angle Q, angle A is the same as angle P. We can use either one. Now, we know that AB and PQ, they are actually parallel. And therefore, angle B is actually corresponding angle to angle Q, and they are similar. So we can say that angle ABC is the same as angle PQC. Its corresponding angle. We can also say that angle BAC is equals to angle QPC. Again, corresponding angle. Therefore, triangle ABC is similar to triangle PQC. The reason is AAA or AA. You can either write AAA or AA, and that's angle, angle, angle. Second proof is side, side, side. This time, no angles are actually involved, but we look at the corresponding side. AB is the corresponding side of DE. BC is the corresponding side of EF. AC is the corresponding side of DF. So, we know that in this case, the ratio of DE to AB must be the same as the ratio of EF to BC. Or you can say that the ratio of AB to DE must be the same as the ratio of BC to EF must be the same as the ratio of AC to DF. So we can write that for triangle ABC and DEF. If it is given that AB over DE is the same as BC over EF, is the same as AC over DF, they are similar triangle by the reason of side, 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 or SSS. Let's have a look at an example. We got triangle PQR and triangle LMN. Again, in this case, there's no angle involved. So what we can write in this case is in triangle PQR and triangle LMN. PQ over LM is 10 over 5, which is 2. QR over MN is 20 over 10, which is 2. And PR over ln is 18.4 over 9.2, which is 2. Now, we know that this ratio to that ratio is 2, that ratio to that ratio is 2, that ratio to that ratio is 2. Therefore, we can say that triangle PQR is similar to triangle LMN because of side, side, side. Right. The third condition we need to look at is SAS, or side angle side. The side and the angle in between. The side and the angle in between. So for triangle ABC and triangle DEF, if it is given that AB over DE is the same as BC over EF, that is the ratio of that, the corresponding sides are same, and the angle B, which is in between the two sides, and angle E between the two sides are the same, we can say that these are similar triangles, which is SAS. Now, an example. We've got two triangles here, ABC and A dash, B and C dash. How do we do it? We need to prove that triangle ABC is similar to triangle A dash, B dash, C dash. Now we can write it this way. In triangle ABC and triangle A dash, B, C dash. Angle B is the common angle. So you know that angle B is here, angle B is here. That's a common angle. Let's look for the ratio. Let's look at this ratio over that ratio must be the same as this ratio over that ratio. So ratio of BA dash over BA is actually 4 over BA is 4 plus 6, 10, which is 2 over 5. Ratio of BC dash over BC is actually 2 over 2 plus 3, which is 5. Therefore, we can say that triangle ABC is similar to triangle A dash B C dash because of side angle side. Finally, last but not the least, we look at RHS, which is right angle, hypotenuse, and side. For any right angle triangles ABC and DEF, if we know that AB over DE, which is the ratio of the hypotenuse, is the same as one of the sides, BC and EF, it could be AC and DF. They are actually similar triangles, which is right angle, hypotenuse, and side. We'll do a proof now. We got triangle ABC, triangle PQR, right? So we can write in triangle ABC and triangle PQR. Angle ABC equals to angle PQR equals to 90 degrees. Now the ratio. Let's do a ratio of AB over PQ. AB is 3 over 2 divided by 2, which is 3 over 2 times half, which is 3 over 4. Ratio of AC over PR is 3 centimeter over 4 centimeter, which is 3 over 4. Therefore, triangle ABC is similar to triangle PQR. Right angle, hypotenuse, and side. Now, I have shown you the 4 ways of proving similar triangle. I will do some example in the class to show you how to actually find sides if you are given certain angles and certain sides. Alright, this is the end of the lesson for similar triangle. I may do some examples on the video if I have the chance. But in the meantime, just stay focused in the lesson, listen to what I teach in the lesson, and I will give you a little bit more example.